is a demonstration on how to solve some of the calculations for displacement, velocity, and time. Right here, I just want to make sure that you're looking at the variables correctly. On the left side, I've got the scalar values, distance represented by a d in meters, speed is a v in meters per second, and time is a t per second. But if you go over to the right, you'll see here that you have the vector quantities that go with those. So instead of a d for distance, we have a d with a little arrow. And that arrow represents displacement. And that arrow shows that it is, in fact, a vector quantity. So anyway, getting back to it, velocity is a v with a little arrow over the top showing that's a vector as well, and time is the same. In the middle here, we see that we have three variables in the same formula. So depending on which one you're being asked to solve for, this triangle here in the middle is an easy way to rearrange a three variable formula. So what you do is whatever is unknown, whatever you're supposed to calculate, you cover up. So if you don't know v, whether it's the speed or velocity, if you cover it up, you'll see that the remaining triangle tells you to take distance and divide it by time. Okay? So that's where this first formula comes from. And then if you cover up the d, because you need distance or displacement, and you're given speed or velocity and time, you take the d and you multiply velocity times time to get it. And then if you need time, using distance and velocity, you have to divide the distance by velocity. So that's just kind of a review. If we go straight to problem 1, I'm only doing the odd problems, remember. Here's what we got. We've got a bullet fired at 486 meters per second. Clearly a speed, I put a v on top of it. I'm labeling my variables really quickly. It strikes a target 220 meters away, that's a distance. What is the duration of the bullet's flight? That means time. What is time? So I know that if I'm solving for time, I need to take the distance and divide it by the speed. And now that we're in second semester, I think it's time that we start using our sig-fig rules in our practice. So I got to make sure my answer has only 3 significant digits, because the number I use to get it with the smallest number of sig figs is this one, and there are 3. Okay, so 220 divided by 486 gives me 0.453 meters and meters cancel, and I end up with seconds, and I box my answer. Pretty straightforward. Okay, next one. How far would an object move in 21 seconds if it had a constant speed of 48 meters per second? So I put a letter D above the how far with a question mark, because that's clearly what I'm supposed to find. Time is 21 seconds. Speed, I represent with the letter V. And then I got to plug it into the correct arrangement of my formula. So D equals V times T. Distance equals speed times time. So 48 meters per second times 21 seconds. Seconds and seconds cancel, of course. And we end up with 108 meters. Only problem with this is that it's got 4 sig figs, and I need it to have 3. My board is sort of misbehaving, so I can round 108 up to, 1008 to 1010, and have 3 sig figs. If you left it as 1008, it really is not the end of the world, not at this point. Okay, number 5 is kind of a monster problem, but we can break it up easily, and I've started you on the way to the solution with the diagram. To the right is a hallway, and so it looks like we've got this confused freshman running up, which I call north, or positive, because direction matters here, and then he changes his mind and realizes that he's lost, and he runs south again. So the trip up is trip 1, the trip down is trip 2, and I labeled my variables accordingly. So 170 feet north, I called distance 1. 150 seconds running north, I called time 1. When he changes direction and jogs south, he runs at a speed of 8.20 feet per second, and he does so for 25 seconds. So that was V2 and T2 respectively. All right, part A, what is the average speed and average velocity for the second part of the trip? Well, this isn't a calculation, it's more of a conceptual thing. The average speed is provided. It is 8.2 feet per second. No direction needs to accompany that because it is a scalar. Now, if I care about the direction, then I'm going to ask about the average velocity. And so, since the second part of the trip, the kid runs down, we could say his direction is south, or we could say his direction is in the negative direction because it's opposite to what I called positive. I think that's easiest, so I'm going to do it that way. Either one is acceptable. All right, part A is done. Part B, calculate the distance and displacement, two separate things, for the second part of the trip. So, I'm going to calculate distance first because I've already put the little formula here. Distance for the second part of the trip equals the speed for the second part of the trip times the amount of time traveled at the second part of the trip. So the speed labeled is 8.2 feet per second, and it looks like we have 25 seconds of traveling. So that gives us, and I think I need 3 sig figs, yep, 205 feet. Again, it is a distance. We don't care what direction, it's just a distance. If I want to turn that into a displacement, I can just look at my diagram and say, okay, on the second part of the trip, he ran in the negative direction, 205 feet. So I'm just going to put a little minus in front of it, and it becomes a displacement. Again, just for the second part of the trip. Part C says, what is the average speed for the first part of the trip in feet per second? So, average speed is simply distance divided by time. It's provided. D1 and T1 are given. 170 feet. Width of visible decimal. That helps you with sig figs. Or 150 seconds. So, 170 divided by 150 is, with 3 sig figs, 1.13 feet per second. So that is the average speed. No direction needed because it's a speed and not a velocity. Okay, now we want the average velocity. I'm going to remind myself of that by drawing a little arrow over the V. And we're looking at displacement over total time. So what is the displacement? Well, the displacement is essentially 170 feet up, which I call positive, plus the 205 feet back down again. So my displacement is negative 35 feet. But what's the total time? The total time is, well, the kid was running for 150 seconds to start with, and then another 25 when he ran back down again. So that is 175 seconds. So his average velocity, which includes direction, is very different from his average speed. So we're taking just his displacement. He ends up just 35 feet below where he started because he ran kind of a long way. And if you do that math, you end up with a very small number, 0.20 feet per second. All right, last problem. A student driving to school, 4.5 kilometers to school. I kind of jumped ahead and I converted 4.5 kilometers to meters because I know I'm going to need my distance to be in meters as it usually should be. So his trip out to school I'm calling D1. And his speed on that trip to school was 20.6 meters per second, which I call V1. Then he comes back exactly the way he came. So he returns home, travels the same distance, slower speed, V2 of 16.2 meters per second. But again, the distance home is the same. So I need to find what the average speed is for the two-way trip. And again, not average velocity, average speed. So the average speed is total distance traveled over total time. Total distance is 4,500 meters times 2 because he goes out and back again. Total time is going to be the time for the trip out plus the time for the trip back, but we don't have either one. So let's just calculate those quickly. So T1 is the distance to school, which is of course 4,500 meters. And the speed that this kid went to school with is 20.6 meters per second. So to three significant figures, let's see, we're talking about 218 seconds. And then the trip back, the distance is of course the same, but the speed is slower, 16.2 meters per second. So it takes longer to get home, to the tune of 278 seconds. Now, if you add those together, you get a total time of 496 seconds. So that's going to be useful. 496 seconds is the total time. The total distance is 4,500 times 2, which is 9,000 meters. So I end up with a pretty simple problem. 18.1 meters per second is the average speed for the entire trip. That's it. So you should be able to do the even ones, but I want you to do exactly what I did, which is to show the formula, your work, check your units, and box your answer. Thanks.